Hi gents, we're going to do 4E now. We're coming to the end because the next two are relatively short ones. So we'll hopefully get chapter 4 done soon enough. So this is to do with the apparent velocities of wind. So if you're going in one direction, it appears to be going in this way. If you're going in that direction, it appears to be going the other way. And just working out what the things are. So we'll go with exercise 4E and page 61, and we may as well just do the first question first. Maybe we'll do question 1 and 2 just as a start off. So to a man cycling east at 4 meters per second, the wind appears to be coming from the north. To a woman walking south at 1 meter per second, the same wind appears to come from the northwest. Okay, if you go and read the work, the example is pretty clear on this. What you want to do is you want to say that the true velocity, sorry, I'll make that green, the true velocity of the wind, we should give that a specific name. So we will call that velocity vector for the wind. The wind vector is going to be xi plus yj. Okay. What we do now is we go and we will say what the man is doing, for instance. So the man's vector, if he is going to the east, cycling east, so he's going in that direction straight across, he's going to be 4i plus no j's. That's what he's doing. Okay, it says though that the velocity of the wind relative to the man, so what he experiences is that the wind appears to be coming from the north. Okay, the wind appears to be coming from the north. So let's just first of all get this thing here. This is VW minus VM. So it's going to be, we're going to subtract the m from the w. My m's and w's are frighteningly close to each other. There's w, there's m, as best I can. So we do w and we take away m. So it's going to be x minus 4 i's, and it's going to be plus yj. Okay, now we just go back to that thing there, saying that the velocity of the wind relative to the man, it appears that this thing here, it appears that when that's happening, that the wind is coming from the north, like that. Okay, so if it's coming from the north, what you'll find is that there's no I component, there's only a j component. So what we can say for this one is we can say that since there's no I component, x minus 4 is equal to 0, and we get that x is 4. That just pops straight out. It's not always quite so simple as that. Okay, so that was the first bit of information that we were given. Next we have a woman. Oh god, okay, so we're going to have to call that VG because that could get really tricky to understand. What's she doing? She is walking south at 1 meter per second. So just like we had before, she's on the way south. So she's going down, no i's, just like the last time, and she's going downwards, and it's 1j. Okay, so the wind for her, so it's the velocity of the wind relative to the girl, we'll say, that is the velocity of the wind minus the velocity the velocity and vector of the girl. Okay, we'll just put this thing up here just to make it easier to see each time. Yj. Okay, we want to subtract one from the other. So the velocity and vector of the wind relative to the girl is going to be, okay, x, well it's x minus 0, so that's just going to be xi, and it's going to be, now careful here, it's yj, and subtracted from that is a minus 1j. Okay, so it's going to be y plus 1 amounts of j. Okay, what are we told about that? We're told that the wind appears to be coming from the northwest. So let's think about that. The wind appears to be coming from the northwest. That's what we have. Now, if you think about that, what you'll find is, sorry, like that. If you are coming from the northwest, directly northwest, we'll say that that's 45 degrees. So we have that this length here is the same as that length there. So we're saying that our x length should be the same as the y length, but very importantly, you know, if we were moving over 5 here, with the y we'd be moving down 5. So our x value is going to equal to minus y, if you want to think of it like that. So in this case over here, what we would be saying is we would be saying that the x value is equal to the opposite of this. It's equal to minus y minus 1. Okay, so you just have to decide what's it going to be, and a little diagram there will help you. I know that they had something on page 60 where you could fill that in, but to be honest with you, I mean, are you gonna learn off 8 different things when you can just think about it whenever it arises, and you should be okay with that. When I say x is equal to minus y, I mean this particular y here, as opposed to what's going on over here. Okay, and maybe I should say like a and b. So a is equal to minus b. So that's our a value. This is our b value. So that's where we're getting that from. We already know that x is 4. So we can just fill that in. You won't necessarily know that x is 4. You might, you know, if the same sort of thing happened in that case over on the left-hand side, you would be left with simultaneous equations, which you can just easily solve yourself. So y equals minus 5, and we get, 5 equals minus y, so y equals minus 5. And there we have it. That is, therefore, what the wind is actually doing. Remember, we had it as xi, so it's doing 4i, and it's doing minus 5j. Okay, it says find the speed and direction. Okay, so we will go and get what the velocity magnitude is of this thing, and it's the square root of 4 squared added to minus 5 squared. 16 plus 25. So that is root 41. That's what it's doing, meters per second. And we'll get the direction here. So it's moving over 4 and it's going down 5. Okay, moving over 4, going down 5. If we're only interested in the triangle, we can just call it 5 itself, just to be able to use sine, cos, and tan. So it's opposite and adjacent. So tan theta equals opposite 5, adjacent 4. Theta equals tan inverse 5/4. Let me see if I have a calculator, and we can type that in. Okay, tan inverse 5/4, and that is, now what did it say, to the nearest anything? Didn't really say much, so we'll say 51.34 degrees. Now, if they're looking for the actual direction, we should just give a little bit to that. What are we saying? We're saying the direction of the wind is east, 51.34 degrees north. That's what we have. So that's part 2 there. Okay, if the man were to cycle north at 4 meters per second, from what direction would the wind appear to the nearest degree? Would it appear to blow? Okay, so what's this man now going to do? So this is a new vector here because he's doing something different. He's going to cycle north at 4 meters per second. So he's not going left or right, and he's going up 4. So that's what he's doing. We already know what the wind's vector is. It's 4i minus 5j. So we're interested in what is the wind doing relative to the man now. So that is wind minus man. Okay, so start with VW, start with that, and take away the 1 on top of it. So we'll just be left with 4i. Start with this, and take away the 1 above it, so that's minus 9j. That is what the wind will appear to do for the guy. So what's it doing? It's moving over 4 and it's moving down 9, moving over 4, moving down 9. If we go and get what theta is there, exact same as before, tan theta is equal to opposite 9 over adjacent 4, and theta is tan inverse that thing there. So it is 66 degrees. Did it want it in the nearest degree? It did. So we would say is that the direction would appear to be, yeah, so you do need to be a little bit careful here. So what are we saying? We're saying that it is going in the direction east, 66 degrees south. Did I say that for the last one? No, foolishly I said east, 51.34 degrees south. So that's the direction in which it is coming. Now, what did they say? In which direction would the wind appear to blow? I think therefore that we would get away with just saying that. Okay, it appears to be blowing in that direction as opposed to it's coming from. So you could work out where it's coming from and work out that angle there. Which would be easy enough to do. Okay. I'll just pause it. I'll just pause it there. We'll check out those. Check out what the next couple of ones look like, and I'll pick one out for you in just a second. Okay. Just actually scanning through the whole thing. I know we started off saying we would do question 1 and 2, but I actually think that we should go on to the tougher one. So we'll turn the page to 62, and we'll do the middle one. We'll do question 8 there. So the wind is blowing with a speed of 10 meters per second. So the thing that they're actually giving you straight off the bat, so giving the magnitude of the vector for the wind. They're saying that's 10 meters per second. So this is, just to be clear, this is question 8 on page 62. Maybe you want to pause the video and try it or something like that, or maybe since we haven't seen too many of these, you can just watch it here and then try the rest of them. To a man who is running, so remember what we were doing the last time. Write down what the vector of the wind is, give it a name, xi plus yj, before we go too much further. Okay, the vector for this guy here, what's he doing? He is running at 2 meters per second in a southerly direction. So he's doing nothing on the i's, and he's going down 2 on the j's. The wind appears to be blowing from the northwest. So first of all, let's get what the wind is doing relative to him. And we know that it is this thing minus the thing below it. So it's going to be xi minus no i's, and it'll be yj minus a minus 2j. So that is going to end up to be y plus 2j's. And it says here that the wind appears to be blowing from the northwest. So it's doing that, okay, directly northwest. That's actually the same as what we had the last time. Third time lucky here. So that's 45 degrees. And again, we just have a little bit of a think about this. If that's A and that's B, if it's perfectly 45, A and B are the same, except the same length, that A will equal to minus B. So this is what we're dealing with here. So we can say that x is equal to minus y minus 2. It's the total opposite to that thing in terms of sign. Okay, so that's our first equation, and you can see here that there's, unlike the last time, it's not x equals something or y equals something. Nice. So what other piece of information is there? There's no second case here. There's no extra person going somewhere like that. So the extra piece of information, the bit of information that we didn't use, was this thing here. And that is that the vector's magnitude is 10. So if we get the magnitude of that vector, and that would be x, square root of x squared plus y squared, that should equal to 10. There's our second equation, and we're just going to do simultaneous equations now. Square both sides. And we're now just going to, it's actually all teed up, ready to go. We know what x is, and if we didn't, we just get either x equals or y equals, and we can just pop it in there. So we can say that minus y minus 2 squared instead of x squared, since x is minus y minus 2. Then x squared is minus y minus 2 squared is equal to 100. Hopefully you know from mathematics class that whenever you have two negatives and it's being squared in there, it's the same as two positives. Because when you go to multiply it, it's a negative by a negative, a positive, a negative by a negative, a positive. So it's actually just the same as having y plus 2 squared. Of course it is, because what you could say is if you have minus y minus 2 squared, okay, let's just think about that, that's minus y minus 2 squared. Another way to write that is y plus 2 times minus 1. That's another way to write down minus y minus 2. It's being squared, and we have the rule that if you've something by something else squared, it's a squared by b squared. So this is minus 1 squared times y plus 2 squared. Minus 1 squared is just 1, and you're left with one amount of y plus 2 squared. Don't know why I show you that necessarily. You don't need to know that here, but you know what? It'll speed things up. It'll speed up your maths if you just know that off by heart, because I'm sure you know what y plus 2 in a bracket squared is. So now you've got that mental shortcut. When both are negative, it's actually the same as them both being positive. So it's y squared plus 4y plus 4. Don't forget the plus y squared, just as a mental thing there. When you go and multiply it out, it's really easy just to leave that thing out. I've seen a few students over the years doing that. Okay, 2y squared plus 4y plus 4 is equal to, well, I should actually just take the obvious step and say minus 96 equals 0. Subtract 100 from both sides. Y squared plus 2y, plus 2y minus 48 equals 0. So this is a handy enough quadratic. I think y, it seems plus 8, y minus 6 equals 0. So we get y equals minus 8. Or y equals 6. Now we have to worry about which one's which. So let's just talk about this in just a second. We'll say when y is minus 8, what would x be? When y is 6, what would x be? And we'll just see which one makes sense, or one of these isn't going to be normal. So if we place 6 in there, we're going to get that x is minus 8. And when we place minus 8 in, minus 8 plus 8, we get 6. Okay, yeah, so it's nicely symmetrical like that, but only one of these is going to be correct. If you remember what the wind was doing here, the velocity and vector of the wind relative to the man, what we said was it was coming from the north west, so it is heading southeast, so it's heading down. It's heading down. Okay, we saw that thing over here. It's on the way down. We know that j should be negative. If you place in 6 in there, that says 8j. It says that you're going on the way up. That does not make sense in this case. So that one we just get rid of. Okay, that one we get rid of. So what is the vector for the wind? It is equal to 6i minus 8j, and we got that via quadratic. So it was a little bit tougher than the first one, certainly where x popped out. Okay, that was actually just part one. The second part probably not as tough as what that one was. This should be easier. If the man reversed direction but continued to run at 2 meters. Okay, so we have a new situation here. What is the guy doing? He was running south, so now he's running north. So he's just going straight up. So 0i, nothing left or right, and he's going up. So that's plus 2j's there. The question is, what would from what direction would the wind appear to him to be blowing? So which way is the wind going? We already know about the winds vector. We just got it, 6i minus 8j. And the question is, what's the wind doing relative to the guy? So it's VW minus VM. Okay, so we start with our W and we take away the one on top. So it's going to be 6i minus 0i's, and it's going to be minus 8j minus 2j's, so that's minus 10j's. Okay, so that is what the wind is doing from his perspective. So what's that? That's moving over 6 and it's going down 10. So moving over 6, coming down 10, and we'll get this angle here. Tan theta is equal to 5/3, or 10 over 6. Theta is equal to tan inverse 5/3. I have a feeling we just did that, did we? I don't know. Was that a previous one? 5 divided by 3. 59 degrees? No, I'm not remembering 59 degrees. Does it say to the nearest? Well, it's very, very close to 59, so we'll just take it that that's what they meant. So the direction of the wind, the direction in which it is blowing, like that, we would say is east 59 degrees south. That's what the direction of the wind is. Okay, so actually, you know what, 4E, it's definitely one that you can do inside a day and know it. That would actually be quite a nice one to come up. I suspect it won't. I suspect it's maybe just a little bit too easy, but it's worth doing. Here's what I would suggest you do. Like start off with an easy one. Start off with question 2 from 4E. That seems to be a good thing to do. And then I would say maybe do 7 and 9, either side of 8. 7 or 9 there, just to try out. And if you have any problems, just drop me a line as per usual. Thank you to all of you for getting in touch, it's good to see you interacting with it. Anyway, take care, all the best.